Hey guys, so today we're going to start a new concept about a word that I'm pretty sure you've heard before, and that word is density. So we're going to do a little bit of an experiment and test out to answer the question, are all liquids the same? Let's get started. Okay, so I went and got some safety gear on. I already had my lab coat on, but I went ahead and put my hair up a little bit more. And of course I got goggles on because these are liquids and they can splash. So I want to make sure that I am safe. So I did get some materials. I have my 4 different liquids. I have a triple beam balance so I can measure mass. And then I have a graduated cylinder to kind of test another property here. And then I did measure out all of my liquids to be the same. They are each 20 milliliters full. So then that's gonna be my control variable. We're keeping that the same. My 4 liquids are going to be my independent variable because I am changing the liquids because my question is, are all liquids the same? So let me kind of get started in our investigation. We're going to be building a density column, and it's something that y'all may have done in the past, but we're going to do it a little bit different. So I'm hoping you can see maybe some different changes or maybe have some new questions. So let's go ahead and get started with that. So before we kind of get started, I did want to show you the 4 liquids. So we know that liquids have certain properties that are similar, such as they have definite volume, but that volume takes the shape of its container. Their mass can be different, and that's some of the properties that we've learned in the past. I also kind of want to talk about maybe the fluidity of different liquids because maybe that plays a role into what we're investigating today. So here you can see I have 4 different liquids. Some of them are colored just to kind of give us a little bit of different color variation. So I'm going to pour just a little bit of this liquid in this container. So we can see when I poured it, it quickly kind of poured out, but it didn't fill the container up all the way yet. It'll eventually get there. It's just going to take a little bit of time. Let's look at this blue one. So we can kind of see this one pours a little bit slower. It looks a little thicker, and it's taking a little bit longer to kind of fill its container up. Let's check out this one. Wow, that one did it really fast, okay? So we can see that just with these 3, we can see there's a little bit different on how they're moving. Let's look at this one. Wow, this one's really slow, okay? So we can kind of see just between these 4 liquids, while we can all agree that they're 4 liquids, their movement is a little bit different. I wonder why that is. Let's see if we can find that out. Okay, so here's our triple beam balance. Now, our triple beam balance is a way for us to measure mass of an object. Remember, mass is how much matter or stuff that's inside a particular substance, whether that substance is a solid, liquid, or a gas. Now, similar to a pan balance, we want to make sure that this is equal on both sides. And we can see that by this 0 being kind of balanced. So this line here kind of evening out indicates to me that this triple beam balance is balanced at this point. So when I'm measuring something, let's say I'm going to measure this liquid here. I'm going to place it on our pan. And what you'll notice is that the pan is going to adjust. Right? Think of it like a seesaw. As soon as I put this on here, this side is now heavier. It has more mass than this side. So we saw this bar kind of go up. Now I'm going to have to move these weights to kind of see if I can even that out. Now, the best way to kind of do this is to start with your ones place. So if we look, we can see this is kind of set up as ones, tens, hundreds. Think of it like expanded form. So here are my ones, here are my hundreds, here are my tens back here. And we can even look, it even breaks down into tenths. So to kind of start this out, I'm going to move my ones place all the way to 10. So we notice that there's no movement. So this tells me that this liquid is heavier than 10 grams. So I'm going to go ahead and pull this all the way back, and I'm going to move my little bar or my weight, okay? And if you notice, there's little notches in there for each one, okay? So we already knew it was going to be heavier than 10. So I'm going to go ahead and move this to 20 and see what happens. Okay, still heavier than 20. So I'm going to move it to 30. Okay, we see that there's a little bit of movement happening, but it's still heavier than 30 grams because this is still higher. Let's move it to 40 and see what happens. Okay, all right. So now we kind of have this estimate of, we know that this liquid is somewhere in between 30 and 40 grams. 30, it was too heavy, but at 40, this side is heavier. So I'm gonna move this back to 30. And now I'm gonna come over here to my ones. Now this is where you gotta do just a little bit at a time. And I'll kind of move it. So we can kind of see it's moving so ever so slightly. A little bit more. And all right, so that's about even. And if we look, okay, we can kind of see that we're gonna have 30 tens, or 30 tens, 3 tens, so for 30, we have 0 hundreds, and we have 1 and 1/10, okay? So think of expanded form. We're gonna add these 3 numbers together. So 30 plus 0 hundreds is still 30, plus 1 and 1/10, okay? So then our mass for this particular liquid is going to be 30 and 1 grams, okay? So I'm gonna go ahead and measure out the rest of these 3 liquids so we can get that data as well. All right, so here is the data we've collected. We know that each of these have 20 milliliters in them, and then I measured the mass of each. So we can see that there's a little bit of difference in their mass, okay? So we're seeing a little bit of differences between our liquids. So while liquids have the same characteristics, there are some difference in some of their properties. So the last thing that we're gonna test is we're gonna put all of these in a graduated cylinder and create a density column. Okay, so let's go ahead and get that part done. All right, so now we're gonna kind of do our density column piece. And this is where you may have seen this before, but I'm hoping now, maybe we have some more questions kind of going into our brain now that we've seen maybe that there are some differences in between the liquids as to maybe why these liquids do what they do in our graduated cylinder. So I do have a graduated cylinder here. It is glass. I'm gonna try to be very, very careful. So the first liquid I'm gonna pour in is, I'm gonna choose to do the blue one first. So I'm gonna get this poured in. And hopefully I can get it all in, but we saw earlier that it kind of moves a little bit slow and I may not wanna come out very much. Okay, so I'm gonna give this a little bit of time to kind of get down. We can still see it kind of running down the side. All right, so we see that it's kind of all flown down to the bottom. Remember that liquids fill its container, so it makes sense that it's running down the container to fill up the bottom. So I'm gonna add in now this red liquid. Okay, so I'm gonna kind of tilt this to the side and I'm gonna slowly run this down. Oop, it's spilling on me. And this is why we wear a lab coat. Okay. So we can see that we're getting some layers stacking up, right? So here at the bottom, if we're thinking back to when we've talked about the word density before, we probably focused on less dense, more dense. So in this particular example, the blue liquid is more dense than the red liquid because it's sunk to the bottom. Our red liquid then would be less dense than the blue liquid because the red liquid is floating on top of our blue liquid. If these two liquids were the same, then they would mix, but we see that they don't. So there has to be a difference in between these two liquids. Let's say if we add another liquid, what happens? Okay. So now we have a little red, white, and blue, but we notice that now this clear liquid is sitting on top of all these other two. So now we can do some more comparison. Our blue liquid is the most dense. It's the most dense because it's below all of these two other liquids. Our clear liquid is the least dense because it's sitting on top, it's floating on top of both these other two liquids. Our red liquid now, we can say one of two things. We could say it's less dense than our blue liquid, but it's also more dense than our clear liquid. So we have a little bit of comparison here. So again, now we have three liquids, still the same kind of properties, but there must be a property that is different that's making them do this. So we have one more liquid. So remember, this was that one that looked like it ran really slow. And what's kind of cool about this, and this is probably my favorite, is you can see it like running down the side between all down the side of all the colors. Okay. So we can kind of watch it, but then look down here. So now we have a fourth liquid. This liquid here is the most dense. It's denser than our blue liquid, our red liquid, and our clear liquid because it went all the way down. We can now say this is the most dense. Our clear liquid up here is still the least dense. It stayed on top. And now we have a little bit more comparison for the blue. It's more dense than the red, but it's less dense than the yellowish one. So I wonder if the data we collected a minute ago with the volume and the mass, I wonder if that has anything to do with why these are stacking the way they are.